Now, in this video, we're going to take up one more problem on shaft, the problem number 28. It reads as the stepped shift shaft shown in figure is subjected to a torque T at the free end and a torque 2T in the opposite direction at the junction of the two sides. Determine the angle of twist at the free end if the maximum allowable shear stress is limited to 60 MPa. The G will be equal to 80 GPa. So here you have a stepped steel shaft having torque T at the free end, which is applied in counterclockwise direction, and a torque 2T in opposite direction at the junction of the two sides. So that means since you have this as in the counterclockwise, 2T will be in clockwise. So determine the angle of twist at the free end. So we need DAB, that is the diameter of the shaft at this is 300 mm. That is, he has given it as 30. So DBC will be equal to 20 mm. So then length of AB will be equal to 500 mm and length of BC is 750 mm. So capital G will be equal to 80 GPa, which is 80 into 10 to the power of 3 Newton per mm square. So tau or tau max will be equal to 60 MPa, which is 60 Newton per mm square. So torque on the portion BC, we need to find out, is TBC will be equal to T, which will be in the counterclockwise direction. So torque in the portion AB will be equal to TAB will be equal to 2T minus T will be equal to capital T, which will be in clockwise direction. So since it is the clockwise, it is positive. You can see here in this section, we can see TAB torque is in the positive direction and the torque on BC will be in negative direction because counterclockwise. Now, thus the two portions of the shafts are subjected to a torque of same magnitude but in opposite direction. So what is T? Will be equal to pi d cube by 16 into tau. Therefore, tau will be equal to 16 into T by pi d cube. As the stress is inversely proportional to the diameter and the torque is same in both the sections, so maximum shear stress will occur at the section BC because of smaller diameter. So the permissible torque T will be equal to pi into 20 cube into tau is 60 by 16. Therefore, torque will be equal to 94.25 into 10 to the power of 3 Newton mm. So angular twist in the free end, that is theta, will be equal to minus theta BC because of counterclockwise direction plus theta AB. So that will be equal to minus TBC into LBC divided by G into JBC plus T into TAB into LAB by G into JAB. So T, therefore, that will be equal to minus T into length of BC divided by G into pi D to the power of 4 BC by 32 plus T into length of AB divided by G into pi into D to the power of 4 by D to the power of 4 AB by 32. So that means the diameter of BC and the diameter of AB. So when you substitute these values, that is equal to 32 into T by G into pi into length of BC minus length of BC by D to the power of 4 BC plus length of AB divided by D to the power of 4 by AB. So close the bracket. So when you substitute these values, you will going to get it as my 32 into torque is 94.25 into 10 to the power of 3 divided by G, that is pi into G. So pi into 80 into 10 to the power of 3 minus into open the square bracket minus length of BC is 750 by D to the power of 4 BC, that is 20 to the power of 4 plus 500, length of AB is 500 by 30 to the power of 4. On further simplification, you will going to get it as minus 0.04884 radians, that will be converted into degrees, that will be equal to minus 0.04884 into 180 degree by pi, which will be equal to minus 2.8 degrees. So this is how you will be able to analyze and solve this particular problem. Thank you.